Got ourselves a 2550 Marshall Jubilee, specifically the model 2550. Customers brought it in saying that it's no-go. That's really about the extent of it. So let's crack it open, take a look, check all the basic things we normally would, and see what's happening. And with the rear panel off, first things we're going to check are, of course, the fuses. See whether anything's blown on that side. And, of course, make sure that they're the right value. Sometimes people put the wrong value in there for whatever reason. Maybe they don't have anything on hand. Yeah, it looks like it's all in one piece. That's a 3 amp. So straight away, this is the wrong fuse. That needs to be a 2 amp. So I'm going to get rid of that. And I'm going to go over to the HT fuse. HT for high tension, high voltage in other words. Throwback to way back in the day that things were referred to as tension on systems like this. That's why it was also called B+, because B was for the B battery, because original radios didn't run on walls voltage, they ran on a series of batteries. So we need 500 milliamps, slow blow on this one. That's a 2 amp. That's a no-no. So someone's put the wrong fuses in here, and here's hoping that means that critical components haven't gone kaboom. Well, one thing I can already tell that we're doing with this particular one is caps. They are going. That's not negotiable. If an amp comes in that's of this age, which according to those caps and the date on the transformer come from 1988, if they're not dead, they're dying. They are on their way. The electrolyte has dried out. There's nothing left inside of there. I'm already going to be inside the amp. It's not that much more to actually get them out and put new ones in, but it means it's going to be less likely to cause catastrophic failure as a result of shorts or something like that in the caps. So this is a non-negotiable in my workshop. It comes in, it's this old, we're doing it, so that way I don't have an amp coming back that's blown up that I have to eat the cost on because something's gone wrong with the caps and they've shorted and taken out a transformer or taken something else out. It might be upside down, but you can see quite clearly here, LCR, those are the original caps that were found in a lot of Marshalls of this era, also all the way up through the JCM 900s. 8804, April 1988. Average lifespan on caps is about 10 to 15 years. That means these are well past replacement. Let's take a look at some of the other bits and pieces and see what else might need attending to. Now remember, when removing a Marshall head from its cabinet, don't use a number 2 screwdriver bit. Use something proper. There we go. Something like this, which is a number 3. See how it's nice and flat on the tip? You're not going to strip your screws out with that. All right, let's assess these preamp tubes. What do we got? Tungsol, made in 2012. Not the worst tube in the world. Electro-Harmonics, made in 2006. That's getting a bit long in the tooth. And finally, another 12AX7 made in 06. So these were both changed at the same time, and then the third one assumptively was changed at a later date. There we go. A pair of JJ E34Ls, slightly different to the EL34s. Not seeing any major discoloration there. Yeah, come on. There we go. And no discoloration there either, which is good. Doesn't look like they've red plated or anything like that. Not seeing any arcing or anything in the socket, which is good. So that can go back in for testing. That one there, that one there. Those can stay there. They feel a little loose in their sockets. So 2 of them have riveted in, third one's screwed in, so that may have been a replacement at some point in the past. Not to fear, we're all good there. Righto, initial inspection time. Yeah, the inside of the chassis doesn't look too bad, not a huge amount of corrosion, which is nice. Yep, those are the original old school ceramic resistors, 1K, yep, it's the right value. Grid stoppers there, yep, 5.6K, standard value. Not seeing anything on the board here that screams out immediately it's gone bad, which is good. Not seeing any scorch marks, not seeing anything burnt, nothing like that. But yeah, those caps are definitely going to be going bye-bye. A little bit of a lumpy lump in the center there. Yeah, the jacks look fine there. Pots look okay. Let's get the correct value fuses in there. Throw it on the variac, power it up slowly, make sure there's nothing too crazy on current draw side of things. Check voltages and see where we go from there. Power on, and roll the variac up and see where current flow takes us. Good, good. Yep. Doesn't look like anything's shorting out so far, which is good. Get up to full power. Almost there. 240. And we're pulling 300 milliamps. Tubes are starting to conduct now, which is good. Heater's on. Transformer's humming away. 0.5 amp idle current. Yeah, cool. So we've got what we need in terms of voltages there on the plates, which is good. Go through, check the other voltages as well now. But at least we know that there's not an immediate short, which is a good thing. Power off. First node is hunky-dory. Second node, which is a yellow one, which goes up to there. Yep, that's good. Second node, which is the blue one, goes down to there. 389, yep, we're good there. Other one's all the way down here. Go red one first. 356, yep. And that one, 335. Cool, so we get voltages where we need to. Now we can check the voltages on the plates and whatnot. Alright. Hazarding a guess, this might be a relatively simple one. Maybe. Let's see what happens when we connect a signal up to it. Give it a bit of a test. You can see 2 of the pots have been replaced at some point in the past and not the greatest of jobs. That's alright, we'll work with what we got. We've got us some power on, all that kind of fun stuff. Let's get SigGen on. Output on. Alright, normal channel now, input gain. That ain't looking too happy. That's jumping around a little bit there. Yep, pots are okay. So we've got signal, it's just not happy. Yep. Full rhythm clip. Yeah, that's tiny. That should be outputting so much right now. That's barely putting anything out. I can't even drive that harder. Yeah, that's pulling next to nothing right now. We've got 2 volts on the output with that output dimed. Where is the signal dropping off? Good question. The tubes are doing their thing. Let's see what happens if we play jiggle jiggle with the tubes a bit. Oh, hello. Yeah, ooh, yeah, there we go. V2, and we mess around with that one a bit. Suddenly we get a lot more volume happening there. And V3, same sort of deal. So I hazard a guess. Oh, there we go. A little bit more volume there. Yep, so V2 is going a little bit funky. Because now when we push it up, now I can hear that transformer hum. That's what I want to hear. Change channel. Oh yeah, that's a loud one. Pull that down. That looks a lot happier. Pull rhythm clip. All right. Change channel. Gain up like mad. Yep. So V2, the socket is a bit funky. We'll contact the customer, see what he wants to do. He wants to opt for a replacement tube socket. Give a bit of a clean out first and retension it, see whether that might help with it. And I'm going to go on with the good old recap as well. Onto it. Old caps. I'm going to transfer that from these ones over to the new ones. You can see they're half the size. That doesn't mean half the quality. These are far more likely to last longer, made with far tighter tolerances, just overall better units. And because of that manufacturing proficiency we've got these days, that's why they're a bit smaller. But the main thing is, they're the same diameter. So that's going to drop straight in, same values, same terminals on there. So we'll be able to make these fit with ease. We're also going to attach these a little bit nicer without flat heads. So the next person in 15 years' time, when they get replaced, can have a far easier time doing it. Let's get them swapped over and get them in. With the caps now in place, we've installed proper mounting hardware this time, so no more fiddling around with flathead screwdrivers. Good quality nylock nuts on there. We've also replaced the lock washers, and we've also replaced the grounding tabs there. Put some nice shiny ones on there, so we've got a nice fresh start to go with. We cleaned underneath where that was going to be making contact to make sure that there was continuity to ground. Now it's time to start soldering things together. With the big filter caps all done and dusted, we now need to turn our attention to the PCB. I've cut out those ones there. Those, of course, are our bias caps. We want them gone and we want them replaced because they're just as old as the others, and if they fail, well, tubes are going to go thermonuclear. So once we've cut them out, what we're going to do now, heat them up from the backside, push them through and remove them that way, just to minimize the chance of damaging those pads. This is back in the days of single-sided, super thin, no through-hole plating PCBs, so it does not take much to mess them up. It really takes very little. What we're going to be putting in order to make sure that this is going to have the best chance at a long life, the last of my Nichicon caps. They no longer do these ones, so we're going to have to find something else in future to do or start using radials. Until then though, I'm going to install these and make this amp ready to rock and roll. After 30 years, this solder will not want to play ball. And so sometimes the answer, when you're wanting to remove solder, is more solder. A little bit there, and we're just going to flow a bit of fresh stuff on there, just to remind it that it's solder. A little bit there, a little bit there. Cool. And so, with fingertips of steel, we heat that up. There we go. Much nicer. So doing it that way, we're able to get those out without damaging any of those pads. And the last thing I want to do when I remove these components is sit there for a while, having to run jumper leads and all that kind of fun stuff, because the pad just decided it wanted to let go because it really takes very little. When we actually remove these, I end up with little bits of jagged solder, and because they're bent and held in place, It just means that they're more likely to catch on stuff. It's easier rather than trying to heat it up and bend them over on the underside. Clip them from the top and push them through. That's the way they want to go. Once those components are out, we want to prep this up for some nice, shiny new solder. Clean the pads off, so using a bit of good quality solder wick. This is a Hacko brand stuff, same as my soldering and desoldering stations. You don't want to cheap out and go for the cheap stuff. A good quality roll might cost you 20, 30 bucks, but it's going to last you years and years and years, even if you're doing professional stuff. But just the amount that you're going to save in time, energy, and effort from not having to mess around with retouching up things because, you know, you overheated the pad or you damaged it or it didn't pick up enough solder, whatever. Spend that little bit extra just to mitigate any issues that might come. Makes a big, big difference. Stay. There we go. Nice. So with those pads all clean and ready to rock and roll, we're going to put ourselves in some shiny new caps. See if there's anything else on the board that needs replacing while we're in here. Flip it back upside and then wait for this socket to arrive. Well, it's been a good couple of days. We've now received a replacement tube socket for this amp. So we're going to yoink this one out and put a shiny new one in there. We're also going to do a little bit of lead dress, shorten some of these leads and make sure some of the others are kind of out of the way to minimize crosstalk and noise and hum that is pretty common of Marshalls of this era. Let's get to it. Presto changeo, we've now disconnected all the cables on there, but we still need to actually remove the socket itself. And this one has been riveted in. It's not as hard as you think to remove. All we need to do is drill the top out just enough to be able to remove this top part. We don't need to drill all the way through, we just need to drill enough to remove that collar around the edge there. Now I'm going to show you how we'd actually remove the rivet. I've already removed one here. If we go for the second one, get ourselves a slightly oversized drill bit. In this case I'm using a 5mm. Give it a bit of drilling down, not too fast. There we go. And we keep going until just like that it starts spinning around. I'm going to use a magnetic tool here just to pick up any extra bits because these are a ferrous thing. I'm also going to vacuum the inside of the amp to make sure there's no shards of metal floating around. There we go. Once we've got that, all we need to do is grab a punch or something similar that can go inside the hole there, give it a bit of a light tap. Old socket removed, now it's time to install the new one. So now that we've got that socket replaced, what we want to do as well is we want to tidy up some of the lead dress and put some shielded cabling in for the grids on V1 because with how they are right now, kind of flopping away in the breeze there, they're very, very susceptible to noise. A lot of buzz, a lot of extra just junk. So, you know, they're running here, that one's running up to there. What we'll probably do is we'll probably do something similar to what they've done on V2. We'll shield it to the cathode. Also a common thing, you can also shield it to high voltage if you want to. Yeah, you've got a bit of a higher risk of something going bad if things go wrong, but AC sees either side, doesn't matter whether it's the positive side or the negative side of the power side as ground. It just wants to get to it. So I'm going to replace those cables with some nice shielded ones, tie them into the cathodes and run them as close as I can to the chassis too, because that's going to help with noise. Nice and flat, nice and short, keep them away from any of the filament lines and that, and see if we can make this a bit of a quieter amp in a good way. So after all that, there's actually a bit more work required than was expected. So after we replaced V2 socket here, powered it up, started testing it, and bam, no signal, which was a bit sort of strange. So V1 was lighting up, was doing its thing, V2 was all hunky-dory. V3, however, over here, lights were out, nothing there. Tested the sockets, tested the pins there. Sure enough, we were still getting voltage there. So there was heater voltage. Check the socket, move it around, nothing's going on. But once the tube was moved around a little bit more, then suddenly the signal came up slowly as the heaters came on. So unfortunately that meant that we had a funky socket for V3 as well. V1, sure enough, we're also getting some intermittencies there as well. Only a little bit, but it was enough when you sort of put a bit of volume through it. So we contacted the customer, had a chat with them, and he was all happy to have them replaced. He just wanted it done once, that way the amp can be enjoyed for many, many more years. We've gone through, we've shortened up some of the cable runs here and relocated them a bit to lower the noise floor. And of course here on V1, both the grids have now been given some shielded coax. The shield has been tied to the cathode of the tubes, and that has lowered the noise floor considerably. So there's less chance of oscillation, less chance of sort of extraneous hum and noise. So you can actually sort of crank this even when it's silent. You're not hearing that big buzz and noise that you normally do with a lot of similar amps of the era. And of course with the amp all powered up and lights, got all the controls just kind of up at 12 o'clock, and you can just barely hear the littlest bit of hiss. Very little. Of course we crank the gain up on both channels, hiss increases a bit. Still very, very quiet though. That's kind of what we want. Push the volume up, bring the gain down a little bit more reasonable. All you can hear is just the whoosh of the hiss. Normal sort of background levels for an amp like this without going absolutely crazy and redoing everything and rebuilding it from scratch. And that little bit of hum, the little bit of buzz and the noise you're hearing will be from the lights and everything that's all up here. Of course, pull the channel. Same sort of deal. Push it closed. Nice. So I'd say this thing is good to go back inside of its case, and we'll give it a bit of a test, have a bit of a play. Alrighty, plugged in, ready to rock and roll. So we're currently on the clean channel. All the controls are straight up at midnight. We'll pull the master up to there as well. And you can hear that's pretty darn quiet. So that's with the cabinet just by itself, mic'd with an SM57. If you hear, it's pretty good. So if we take this and we add some guitar volume to it now, we should be able to hear sort of what's going on. So actually a pretty decent clean tone. For an amp of this era, it doesn't sound like it's half choked off or anything like that. And if we give it a little bit of neck pickup and the bridge pickup together, it's nice. What's cool about these as well is, of course, you've got the rhythm clip option, which adds in some clipping diodes into the clean channel that also affects the dirty channel as well. So it's that classic 80s modified amp tone. So you've got the tubes clipping into their sort of range and getting saturated, but you've also got the clipping of the diodes in there as well. That's a pretty cool kind of tone. So if you don't usually go into a full clean type setup, you can have that set there, because the input gain also controls how much extra distortion, how much stuff you get from your lead channel as well. Speaking of, now that we've had a bit of fun with that, let's go over to Dirty Town. So now, once again, volume's off on the guitar and we can hear it's just a bit of a whisper. It's pretty good. So your lead master is going to control the balance between your clean input and your dirty input. So yeah, let's just have a bit of fun with it and play with some bits and pieces and see what happens. So that's now one happy Marshall Jubilee ready to go back to its customer. Of course, we've got a lot more repairs coming up in the workshop, including another Marshall, an SLO, Frankenstein Jr., a whole bunch of other cool things. And let's not also forget, some pedals, got some guitars, all sorts of cool stuff. So if you want to see us pump out more content, want to see more videos, more tech stuff, more demo things, then of course, click the like, hit subscribe, share it around, ask questions, do all that good stuff. Because the more people who interact with us and the more people who say, cool, I want to see more stuff, the more time that we'll put aside to actually getting some more stuff out. So until next time, catch ya.